second. No, hold on, it's nearly. Alright, let's have a look at the homework. Do you have the questions or do I need to open them?
Do you want to read it?
I'll just open it here, it's alright.
You can have my mobile, I have it in my paper.
Let's see, physics, atoms. Which lecture number is this? Is it number 2? No, it's half-life.
Yeah.
Radon 222.
Is it, but is it half-life?
No, it's not half-life.
No?
Half-life.
It is half-life.
It is. Yeah, it is.
Who said it wasn't? It's half-life, is it?
Yeah.
Yeah, okay. Right, so the first question, let's see. This one. Yeah.
No.
No? You just said radon 222.
Yeah, but we have the 2 questions.
What? Not this.
Not this.
Did I do 2 lessons? Is it?
No, this is the same thing.
Oh,
Maybe
right.
you need to explanation
I don't know, okay. Right, okay.
No, I did this one, yeah, I did this one.
Okay, good. Radon 222 has a half-life of 2.8 days. How long until less than 1 gram of radon 222 remains?
That's 2.8 days.
Yeah.
28.
28? That's 2.8. Oh well. You didn't see it. That's okay. So, right, let me get the calculator. So, how much do I want? 1% or something, is it?
Yeah.
And 2.8 days is a half-life. So let me see. If I start off with 100% and divide by 2, that's 50. That's 1 half-life.
Can you do that on the writing too?
Yeah, okay. Let me just. It's not work. Come on. There we go. Right, so where's my. Here it is. Oh, come on. Right. Running low on ink. Now seriously, there's a little nib on the top that gets worn down and it has to be replaced for the sensor to pick it up. There we go. Right, so I want part A, 100%, no, it's gone again. Right, so part A, goodness sake. I'm just trying to refresh it, you know.
He succeeded to get that fake password.
Whose password? Someone's? Good for you, I guess. Password for what?
Facebook account. Twitter account. You want to know someone's private messages?
Yeah, Twitter private messages, that's a good one. Come on. I know you can do it. Right, I'll have to use the cursor. It's going to look ugly. It started off with 100, and then we have after 1 half-life 50, and then 25, and then 12.5, so 12 and a half, And then after this, it's what's it? 6.25. Then after that is 3.125. Then after that is 1 point something. Yeah, and then after that is less than 1. Yeah. So the last one here. So how many half-lives is that? 1, 2, 3, 4, 5, 6, 7, isn't it? 7. So 7 half-lives required to get to less than 1%. So 2.8 times 7 is 19.6 days. So the answer is 19.6 days. Do you get it, Fahad?
No.
Do you understand it now?
Almost.
So that's 1, 2, 3, 4, 5, 6, 7 half-lives. So 7 half-lives. So that's about 19.6 days. That's part A. Is that okay?
No.
Can I do part B? What is the decay constant? Okay, so what's the formula for the decay constant? Let me see. It's half-life equals log 2 over lambda. Isn't that it? So decay constant is log 2 over half-life. Now you can use seconds or days. So you can say the half-life is log 2 divided by, is it 2.8 days?
Yeah.
Is it? No, really, is it? 0.248 per days. Or if you want to do it as seconds, I'll try that again. Log 2 over 2.8 times 24 hours times 3 to go on. And if you want it as seconds, it would be 2.87, and it'd be micro per second, microhertz. Yeah? Okay. So that's the B part. The C part, what is the initial activity? Okay, so we can use the formula A equals minus N lambda. Now this is where I didn't give you the molar mass. We'll take it as 222 roughly. So the number of atoms, well actually how many moles do we have? Let's do that on the side. How much gas do we have? 25 grams. 25 grams. And what's the molar mass roughly? 222 grams. So the number of moles, 222 grams. So 25 divided by 222. So that's roughly 0.113 moles. So as atoms, I multiply this by Avogadro. What's Avogadro? 6.02
times 10.
minus 23?
No.
Positive 23, of course. So that would be 6.78 times 10 to the 22 atoms. Do you want to use days or seconds? You want to use days? Okay, well then if you use days, I multiply this by 2.8, and you would get minus 1.898, so 1.9 times 10 to the 23. Now, but it's the units, not BQ if you're using days, because BQ is destructions per second. So it'll be destructions of atoms per day as the unit. So it'd be atoms per day. Now, if you want to use BQ, you're going to have to you're going to have to use this one in seconds. This one, sure. 6.78 times 2.8 times 10 to the 22. Yeah? What did you get?
17.
No? 17
Yeah.
times 10 to the...
No, 1.9
Yeah.
times 10 power 17.
Well, how did you get that? What did you multiply?
I multiplied this 6.78
Yeah?
to the 2.87.
Yeah, but I said I'm using days.
Well, there are 3 people.
I said I'm using days.
So I use
You used this one, seconds,
Yeah.
did you?
Mm-hmm.
Yeah. I was using this one. Oh, hang on. But actually, you were right to say that I was wrong, but not your answer either. 6.78 times 10 to the 22 times 0.248. Okay? 1.7 times 10 to the 22.
4 seconds.
Atoms per day. Now, do you want seconds? Of course you do, because you use seconds. So, in seconds, I think that's the answer you have, Fahad. What is it?
1.94 minus 1.94.
Yeah, minus 1.94 times 10 to the...
17.
And this is BQ.
Yes.
Okay, thank you. Next, how long until you have 1 gram remaining? Right, so we'll use the formula we've seen before, that M equals M0 E minus lambda T. Now look, listen carefully please. If I use here per day, then the answer I get for T will be in days. And if I use per second, the answer here I'll get is per second. I am going to use days, because the number will be quite large. So, we want 1 gram, and how much do we have to start? 25 grams. And what's the lambda in per days? 248 T. So the T will be in days. 1 divided by 25, log the answer, divided by minus 0.248. So T will be 12.98. So the T will be roughly 13 days. All cool?
Yeah.
E. If the room was 20 by 30 by 3, did you have this one as well, or did I add it in afterwards?
What?
Part E.
No,
Yeah. If the room was 20 by 30 by 3, what's the density? Alright, well that's stupid. Density is mass over volume when there's 1 gram present. So 0.001 over 20 by 30 by 3. What's wrong?
Alright, yeah. You change gram into kilogram.
Ah, yeah, it's the normal thing for the density. So you have 5. Well, I mean, if you wanted to use grams per meter cubed, there's nothing wrong with that. Is that what you wanted to do? Yeah, well, I'll do it this way first. Oh, well, okay, we'll do grams per meter cubed, not that it, but then it should be grams per centimeter cubed. So we'll do it 1 gram over 20 meters is how many centimeters? 2,000. 20 by 1,000 by 300, is it? Oh wait, it's 10 meters, isn't it? 20, oh by 30, sorry. 20 by 30 by 20 by 30 by 3, so this should have been a 3 here. Was that your question? Yeah. You know why it's 3,000, don't you? Yeah. It's tiny. 5.56. Oh my goodness, 10 to the minus 11 times 10 to the minus 11 grams per centimeter cubed. What's nano is minus 9, isn't it?
Yeah.
So this will be 0.06 if you want. Nanograms per centimeter cubed. So, yes.
If I have this answer in grams per meter,
That's fine.
that's fine.
I mean, if it's the right answer.
Okay, yeah, I have 5.56 times 10 minus 4 grams per meter.
Meter cubed.
Yep.
No, you just added the cube.
The answer is 6. I got to get
Answers no. If you didn't have the cube in the exam, I'll take a mark away.
I know.
Finally, what is the, if the, I did say it, if the molar mass is 222.
No, not for the reactor.
Oh, for earlier.
Yeah.
Ah, okay. I said it here, fine. If the molar mass, for this one here,
Yeah.
okay, well I'll just move that up into the question. If the molar mass is 222 grams, then what is the molar density? Moles per litre. So,
Moles per liter.
isn't that what you call it in chemistry? Moles per litre. It's molar density.
I think concentration.
That's the word. I couldn't think of the word. Well, it's molar density. Moles per meter cubed. Concentration was the word.
Yeah.
All right.
Molar density.
You understood what I meant, didn't you?
Molarity.
That's the one. Molarity. I couldn't remember these words yesterday. Right. So for the molarity, you need to know how many moles you have and what's the volume. So we only have 1 gram left, and the molar mass is 222. So we don't have many moles of radon. We only have 1 divided by 222. So we only have a very small amount. Pen's gone again. No. Come on. I can do it. Well, I'll just have to say it. Right, so what did you get for the number of moles? 4.5 times 10 to the minus 3. No, that's just for the number of moles. There's 1 gram and there's 222 grams in a mole. So 1 divided by 222 is that number. That's how many moles you have, yes? Now what's the volume? Well, we can get the volume in meters cubed, but we use litres. How many litres in a meter cubed?
10.
No. 1,000, thank you. So, the room is, listen carefully because I can't write it right now, so listen carefully. The room is 20 by 30 by 10. That is 6,000 meters cubed. How many litres in a meter cubed?
6 million.
No,
1,000.
1,000. 1,000,
Yeah.
not 6.
1.
Think carefully. A room that's 20 by 30 by 10 is only 6 litres. You know how much a litre of milk is, don't you?
So
Yeah.
only one.
So, if the room is 6,000 meters cubed and there's 1,000 litres in a meter cubed, then that means we multiply this by 1,000 and there's 6 million.
That's what I said, 6 million liters.
I didn't.
I said that was the first thing I said.
I didn't hear the million part, I just heard the 6.
He said that.
You can vouch for this? Alright. Fine then, congratulations to you on multiplying. There are 6 million litres. So, what do we take? 4.5 times 10 to the minus 3 divided by 6 million. Alright, KJ, you give me the answer, so.
7.5 times 10 to minus 10.
And the unit for molarity, or concentration, if you will?
Capital M.
Capital M. And what is capital M? It's moles per litre.
Yes, that.
Okay, I can close this?
Did you ask by